Welcome. You're on The Fringe Show. I'm your host, Tatiana Zalan, and I go live every Friday at 2 p.m. Dubai time. The Fringe helps you to navigate the rapidly changing world and improve the odds of your success. Here we discuss technologies, startups, and mental models of successful people so that you too can take advantage of the opportunities in the new digital world. Today's episode number 42, and I decided to talk about the artist and AI, how this relationship evolves. So, the artist, on one hand, something very creative as a process, and on the other hand, technology, artificial intelligence. And the trigger for the show was a recent announcement by Refik Anadol, who is a Turkish American digital media artist who sold his work as an NFT at Christie's for almost $1.4 million. He works in the style of generative art, and that particular piece was Casa Batlló, Living Architecture. It's a very famous building in Barcelona, those of you who've traveled to Barcelona maybe, and that's one of the UNESCO heritage buildings as well. So he did art and then into an NFT. I won't really be talking about generative art today. It's a really large, very interesting topic. Maybe it's worthy of a separate episode, if you will, on the Fringe Show. But what we see that new technologies, and particularly AI, have penetrated not only traditional technical professional spheres, if you will, but also the artistic world, changing the nature of the creative process. We're now reaching the time when a computer can become not only a tool to aid a human creator, but really a separate creative entity. And this is exactly what I would like to explore. Can AI be an artist? And if so, what is an artist? Or is their eye simply a tool, like a paintbrush? Is it some sort of collaboration between an artist and machine that explore new digital forms? By the way, AI's creative capabilities aren't limited to artwork itself. People are building all sorts of intelligent systems that can write poems and songs and story plots, and probably even some other creative jobs as well. So what I would like to explore in this episode is something around the pioneers of computer art. Also, what are the AI techniques and technologies that are helping artists right now? As I said, I won't touch upon things like generative art, but there are other tools as well. What is the most significant art? Hopefully, I will be able to show you a couple of pictures that have attracted a lot of attention, paintings, but also NFTs. How can we understand the relationship between the artist and AI? And that brings us to an even broader topic of what is creativity and what is a human being's creative intelligence, and how does this relate to artificial intelligence? And I'll start with Harold Cohen and Aaron. So who is Harold Cohen? It's typically what I see a lot of is that when we're discussing computer art, artificial intelligence art, then crypto art for that matter, we somehow tend to think that it's a new phenomenon, that it appeared quite recently, maybe in the 10s, around 5, 6 years, 10 years ago, but it's not correct. Actually, there are people who were very early pioneers in computer art, in algorithmic art, and in generative art. And one of these pioneers was Harold Cohen and his computer system, Aaron. Harold Cohen once famously said, and that was in the late 80s, that it took him 20 years to teach Aaron to draw. And then his second ambition was to possibly teach him to color before he dies. Well, actually, he achieved that before he died. He was a very talented artist, an impressive engineer, a very important bridge between the two worlds. His work really defined the first generation of computer-generated art. His system, Aaron, is one of the longest running and continually maintained AR systems in history. It's a robotic system. It's been developed over many years, and it's literally you can pick up a paintbrush and with a robotic arm and paint on canvas on its own. That's what Aaron can do. Cohen and Aaron had a particular love for organic forms. They loved nature, gardens, flowers, and human bodies, and this is what you can see a lot of in his pictures. Aaron draws people in botanical garden, not just making a copy of an existing drawing, but really generating a lot of unique drawings on this theme if needed. Aaron has never seen a person or walked in a garden, in a botanical garden, but has been given knowledge about body postures and plants by means of rules. So it's sort of a rules-based system. Aaron's knowledge and the way Aaron uses knowledge is not like the knowledge that we humans use and have. Human knowledge is based on multitude of senses, on our experience in the world, and people experience in the world through their bodies, through their brains, through their reproductive systems, and of course computers don't really do that. But just like humans, Aaron's knowledge has been acquired cumulatively over many years. Once it understands the concept of a leaf cluster, for example, it can make use of that knowledge whenever it needs it. One of the main feature of any new artistic movement like Cubism or postmodernism, if you will, is that the artists who are part of this movement, and particularly one artist who is kind of the pioneer in this genre, they're rule breakers. They break the rules, they push the boundaries, and so on. Aaron cannot do that. It can't break the rules. It cannot imagine the possibility of drawing a human with one leg, for example, or other forms of abstraction. So Aaron's creativity in this sense is quite limited. Cohen himself wrote extensively about Aaron and looking at these questions between, related to computer-based artistic systems that's raised both in the computing world but also in the artistic world. Some of them, he also gave a lot of interviews, and some of the questions he was asked repeatedly say, is Aaron creative? Well, Cohen certainly thought that it was not as creative as the creator, that is Cohen himself. Who was the artist, Cohen or Aaron? Cohen, he compared the relationship between himself and Aaron as that of the Renaissance painters and their apprentices. So he didn't have a very high opinion of Aaron in that sense. A third question that he was always asked is Aaron creating artworks, and is it the way that he is doing this? Is this a sign, evidence of computer intelligence? And on that particular question, Cohen was somewhat ambivalent. Aaron never worked to improve itself, so a sure sign of intelligence if you can improve as a human being what you do. Aaron didn't do that. And at the same time, Aaron did just like humans, human artists, taking knowledge of forms and applying them to the creation process. Harold Cohen passed away in 2016. He lived a very long life. He died in his late 80s, and his career spanned well over 60 years. He exhibited work around the world in dozens of exhibitions, and his works are held in major museums like the Victoria and Albert Museum in London, a museum in Amsterdam, and also the Tate Gallery, and the San Francisco Museum of Modern Art. So as you can see, Aaron's work was appreciated in some shape or form. And commenting on Aaron's passing, another legendary early computer artist, Frida Naki, said once, Harold was the lonesome rock of rule-based algorithmic art. Nobody in the world did anything in fine art as courageous, as daring, and as successful as he. His approach was unique in all its facets. His rich work stands out unparalleled. And now hopefully I will be able to show you one of the pictures that Aaron created and Cohen created with his help. So that's the picture. Let me blow it up for you a little bit. Created now with the Computer Museum in Boston. As you can see, as I said, it's very much organic forms. He loved Aaron and Cohen, loved plants, loved nature, loved botanic gardens, and so on. Now let me get back to where we are. So that's Cohen, and that's his work, very early work in computing, in computer art. Let's now have a look at a different style, and it's called neural style transfer, sometimes called art style transfer. It's a different technique. It's an optimization technique which is used to take two images, a content image and a style reference image, such as artwork by a famous painter, and blend them together so that the output image looks like the content image, but painted in the style of the style reference image. This neural style transfer consists really in the transformation of an image into a similar one that seems to have been painted by an artist. If we're, say, we love Vincent van Gogh, we absolutely also love German Shepherds, we may like to create a picture of our favorite dog painted in Van Gogh's, say, Starry Nights fashion. The key technique that makes this neural style transfer possible is a convolutional neural network. CNN is another word for saying that. And the first algorithm was invented by Gaddis and his colleagues. That was in 2015. They base their approach on this unique ability of the convolutional networks to be able to extract features of different scales in different layers of the network. All neural networks, like deep learning networks, they try to imitate human brains with its multitude of connections and multitude of layers, multitude of neurons, and so on. So this is what the computer scientists do. And we know that deep layers of neural networks extract more general features. And in the case of CNN, the lower layers of the network extract very local features that may be edges and corners and colors. And in deeper layers, these edges and corners are combined together to represent global features. By global features, we mean features like shapes and faces, sometimes whole objects like computer keyboard, and so on. So that's an instance of deep learning in artificial intelligence. And many people think that neural style transfer is more of an impersonator, if you will, than a creator. Again, let me show you what I mean by saying neural image or neural style transfer. Sharing. Let me share here my screen again with you. Here, as you can see, there is content, which in an Eiffel Tower, we love Van Gogh style, that Starry Night. And the recomposed image in itself is the Eiffel Tower, which is painted in the style of Van Gogh and Starry Night. This is another technique that a lot of artists are using as well. So deep learning AI, that's where we've just been through, is really good at recognizing things, but it's not very good at creating them. So the question that a lot of computer scientists are themselves, and artists as well, can machines come up with images by themselves? Right? And this is exactly the question that Ian Goodfellow asked himself in 2014. I mean, Ian Goodfellow is a computer scientist, and he had this very genius idea of pitting two networks against each other. The technique, this technique in particular, sparked huge excitement in the field of machine learning and artificial intelligence, and it turned its creator, Ian Goodfellow, literally into artificial intelligence celebrity almost overnight. And he came with the idea of this, what we call GAN, generative adversarial networks. GANs are like a machine learning framework that consists of two neural networks, the generative network and the discriminative network. And they play essentially a zero-sum game. The magic of GAN lies in the rivalry between these two networks, between these two nets. It mimics the back end and forth between, we almost call them a picture forger and an art detective that repeatedly try to outwit one another. Both networks are trained on the same data set, as you know, in computer science. Most systems are trained on very large data sets, and this is no exception here as well. The first neural network, the generator, is charged with producing artificial outputs, such as photos that can be handwriting, and they should be as realistic as possible. And the second discriminator compares these with genuine images from the original data sets and tries to determine which are real and which are fake. On the basis of those results, the generator adjusts its parameters for creating new images. And so it goes over and over again until the discriminator can no longer tell what is genuine and what is not. Over time, this process eventually generates new images that look like they belong in the initial data set. Essentially, it is a system that pits algorithms against each other in order to improve the quality of the results, the quality of the output. One algorithm generates data and the other one competes with it, discriminating between the real and false data. And so the process goes on, and this is why the system itself is described as adversarial. I'll show you one of the most famous pictures that's been produced using this technique, generative adversarial network, or GAN. And it is famous for a number of reasons. So as you can see here, that's a portrait that's been done completely by AI using GAN. And here you can see a co-founder of the team of French entrepreneurs from a group which is called Obvious, and this group in particular produced this art. So what's the story behind this art? Let me tell you a little bit of the story here. That's a painting generated by artificial intelligence, and the interesting bit of it is it's sold at an auction for nearly $500,000. The painting itself is called Edmond de Bellamy from the La Famille de Bellamy. Bellamy is actually a tribute to Ian Goodfellow. Goodfellow can be translated as Bel Ami from English into French, and that sold at Christie's, New York, for more than $400,000. Including fees, almost $500,000. Christie's by themselves were not particularly very optimistic about the price. They set the auction price, maybe they said that it will go for $7,000, $10,000. But interestingly enough, it went for a lot less. We still don't know the buyer. The buyer wanted to remain anonymous, and he bid, or she bid, by phone. This portrait was created, as I mentioned, by Obvious, which is a French art collective. It's marketed by Christie as the first AI-made painting sold at an auction. As we see, it's not really the first computer-aided painting, but it's probably one of the first that sold at Christie's, definitely. So how did they create this art? They fed thousands of portraits into an algorithm, effectively teaching the machine portraiture techniques of the 18th century. The result was a series of 11 images, and one of them was Edmond de Bellamy and fictional family, the La Famille de Bellamy. Not everyone was happy with the sale. Some criticized the methods, Obvious use. They're saying that GAN is employed and has been used by artists for many years, and some of the artists who were using machine learning anyway said Edmond de Bellamy was like a connect the dots child's painting. And so there was a lot of controversy after this particular auction about what constitutes art and how can we appreciate art. So that really raised the fundamental question of whether the images produced by these networks can be called art at all. One way to do it is to conduct some kind of a test or visual test. In computer science, there is a test which is called Turing test after Alan Turing, which is really trying to discriminate whether a program and output has been created by a human or by a machine. And so they decided to do a similar test, similar visual Turing test for computer-generated art, if you will. And this experiment was run not in relation to Bellamy, but generally we do know that these experiments were done when mixed human-generated art and art from AI were presented to people at the same time, and they were mixed, so not very easy to understand what's what. And people were asked questions like, do you think this painting was produced by a machine or a human artist? And also some indirect questions were asked like, how inspiring do you find this work? And then they measured the differences between the responses in the human art and machine art. And what they found is very interesting. There was very little difference. And actually sometimes some people were more inspired by the art that was created by the machine. Can such a poll constitute proof that an algorithm is capable of producing indisputable work of art? Well, perhaps it can, if you define a work of art as an image that's produced by an intelligence with an aesthetic intent. But if you define art more broadly as an attempt to say something about the wider world, to express one's sensibilities, one's anxieties and feelings and emotions, then probably AI art must fall short, because no machine mind can give things that people urge and some people never will. Co-founders of the office of the cooperative that created the painting said that for sure the machine did not want to put emotions into the picture, and in the research terms, the idea of a robot having an open world experience and using it to make something new, that's pure science fiction right now. And that also leaves an open question of ownership. Is it really the algorithm who created Edmond de Bellamy, or is it the signature of the, and that's what the signature on the portraiture itself implies. You could also say that at this point, it is probably a collaboration between two artists, one human and one machine. And all these questions that have been raised by the auction, by this particular painting, raised really lots of questions in the field of computational creativity. And computational creativity is a new field in artificial intelligence that looks at creativity by machines. It has this basic understanding that a creative idea is a novel and valuable combination of known ideas. They say that nothing is arising from emptiness. Every creative work or creative idea is always embedded in the historical or cultural context. It is a fruit of the cultural intelligence and the lived experience. And they're saying that the new thoughts, so-called new thoughts that are originating in the human mind are not completely new, because they have origins and seeds in representations that already exist in human mind. So in other words, all these physical laws and theorems and musical pieces can be generated very easily from a finite set of existing elements. And what that means is that creativity is an advanced form of problem solving. This is how they see it. And that involves memory, analogy, learning, reasoning, under constraints. And it is therefore possible to replicate this kind of problem solving by a lot of computers. And that leaves us with a number of unanswered or partially answered questions. And this is how I want to kind of finish this show, with three at least unanswered or partially answered questions that are interesting to me, and I invite you to think about them as well. The very first one is that can there be art without emotional and social message? Can it be reduced in a vast form of problem solving, as the field of computational creativity would say? And yeah, well, can we think about it as an image produced by an intelligence with some form of an aesthetic intent? So that's one of the first questions. How about the emotional social message? The other one is the question that it raises is, what is intelligence? And perhaps one of the best answers to this question is coming from David Deutsch. David Deutsch is a quantum physicist and philosopher of science as well. And in particular, his book, The Beginning of Infinity, is a really great exploration into human creativity, human intelligence, and how humans come up with explanations around the world. And what he's saying is that intelligence in the general purpose sense that Turing meant is one of constellation of attributes in the human mind that have been puzzling philosophers for millennia. And they include consciousness, they include free will and meaning. So philosophers have been mulling over these questions for many, many years, and they haven't found any answers yet. So at the present state of the field, a useful rule of thumb, at least for him, is if it or something can already be programmed, it has nothing to do with intelligence in Turing's sense. If you can't program it, on the other hand, you clearly haven't understood it. And in his mind, the field of artificial intelligence, and particularly artificial general intelligence, which is the one that's very similar to how humans think, has made no progress because there's this unsolved philosophical problem at its heart. We do not understand right now how creativity works. If this problem is solved, then probably we will be able to program it, to code it. And mind you, code is just another language. And the third question that it raises is, well, what constitutes value in AI-generated art in the absence of the artist as an author? I have a show that explicitly focuses on what constitutes value in crypto art, in digital art. I come back to this topic many, many times. And it's very clear that in traditional art, in computer art, it's a lot about the artist himself or herself, about his fame, reputation, the story behind, the narrative that he or she would like to tell the world. And that's a very significant part of the value. Then there is artist following or community. And can there be community around some sort of an inanimate object or an inanimate entity, if you will, the code, the program, the artificial intelligence? So I think these are three very interesting questions that we can certainly explore more and more. And there are not very good, satisfactory answers to these questions as yet. But I would like really to hear from you what you think about that. What constitutes value? What makes a piece of AI-generated art valuable, apart from novelty? I understand novelty may be one. What is intelligence? Do we understand creativity? And what art can be without this emotional and social message? Well, thank you for listening today. Thank you for joining. I hope you've learned something. I hope you will think about these questions in a lot more depth. And I'll see you next Friday at 2 p.m. Dubai time. And now it's time for some music, as always.